Welcome to the Deep Dive, where we really try to boil down the key insights from our source materials for you.
That's the goal.
So today, we're jumping into something pretty innovative, technology that's changing, well, how industries think about safety. Picture this: a busy factory, lots of powerful machines, people working close by. How do you keep everyone safe, but without, grinding everything to a halt?
Yeah, that's the classic problem, isn't it? That constant balancing act between keeping workers absolutely safe and keeping the lines running, keeping productivity high. And the materials we looked at, they offer a really interesting perspective on how new tech is tackling that exact challenge.
Right, and the deck we're focusing on today is 3D safety radar. We've got information here from PowerSafe Automation and also from Inspect. So kind of different angles on this cutting-edge solution.
Exactly. And our mission here really is just to unpack how these radar systems actually work, where they really make a difference in, real industrial settings, and maybe what it all means for the future of these kinds of environments. We want you to get the core ideas pretty quickly.
Okay, let's dive in then. The basics. What exactly is the 3D safety radar sensor, and why the term volumetric? What does that mean?
Right. So unlike, say, a light curtain that just creates a flat 2D plane, these things create a 3D virtual safety area. Think of it more like an invisible bubble or maybe a cube around the machine. It's monitoring that whole space.
The entire volume, okay.
Exactly, hence volumetric. And crucially, these aren't just any sensors, they're SIL rated.
The SIL rated.
Safety integrity level. It's a formal standard, a rigorous one, for industrial safety components. Means they're certified for safety critical tasks.
Got it. So it's building this 3D zone. It's certified. What's its main job inside that zone? Our sources talk about safety-rated restart prevention, data access detection, and anti-collision. How does it actually do that? It says, by looking for moving objects large enough to be a person through radio signals.
Precisely. It uses radio waves. It sends out signals. They bounce off object, people, forklifts, whatever, and then it reads those returning signals. From that echo, it figures out exactly where the object is, how big it is, if it's moving, all within that 3D space.
Okay, radio waves. And are they safe?
Oh, absolutely. The materials are clear on this. The radio waves used are completely harmless to human health. That's always an important point to make.
Definitely. Good to know. And these zones aren't tiny, right? The coverage is pretty decent.
Yeah, it's significant. We're talking up to a 9-meter range, typically within about a 100-degree field of view. So quite a large protective area.
Okay. Now let's think about the factory floor itself. Anyone who's worked in one knows it's, well, often not the cleanest place. What kind of things usually mess up sensors in those environments?
Yeah, that's where radar really starts to stand out. Because your traditional optical sensors, think cameras, light curtains, they can really struggle. Dust, smoke, mist, shavings, even bright light changes. Those can blind them or cause false alarms. That's where a radar has a big advantage.
Okay, so PowerSafe Automation, their material mentioned that the radar is susceptible to dust, chips, fog, oils, water rain particulates, shavings.
Right.
But interestingly, it says it will still default to sense movement of large objects even then. So it maintains a basic safety function.
A fail-safe kind of mode. But then you look at Inspect, and this is where it gets particularly interesting. They state their technology is resistant to disturbances caused by light, dust, swarf. Swarf is like metal shavings and any other environmental factors.
Resistant. So not just susceptible but defaulting, but actually resistant.
Yes. They specifically say immune to light, immune to debris, immune to smoke, immune to fluids. That's a strong claim.
How do they manage that?
They mention using sophisticated FMCW radar algorithms. FMCW stands for Frequency Modulated Continuous Wave. Basically, instead of just a simple pulse, it's constantly sending out signals that sweep across a range of frequencies. This lets it very accurately measure distance and velocity, and crucially, it helps the algorithms filter out all that environmental noise like the dust, the smoke.
So it can tell the difference between, say, a person and just a cloud of dust.
Exactly. The whole point is to reduce false alarms and increase productivity. Because if your safety system is constantly tripping because of steam or dust, that's a huge productivity killer. This immunity aims to solve that.
That is a key difference. And Inspect also mentions milliseconds reactivity, super fast response time.
Yeah, very quick reaction, and also 100% privacy protection.
Right, because it's radar, not cameras, no pictures of people.
Exactly. It just sees objects based on radio waves, not images.
Okay, so we've got this more robust, reliable sensor tech. What does that actually mean for a facility day-to-day for the people working there?
Well, if you step back and look at the big picture, it really changes the game. These systems allow you to provide maximum safety for operators while dramatically improving productivity. It's about finally letting people and machines work together at last, as one source put it, safely, without compromising the workflow so much.
That sounds ideal. And the applications seem really broad. The sources listed quite a few, like restart prevention. That's for machines, robotic
Yeah.
cells. You step in, it stops, and critically, it stays stopped till you're safely out.
Right. Prevents those unexpected restarts.
Right.
Crucial.
Then there's protection from access to dangerous areas generally,
Yeah.
and anti-collision systems. I can see that being huge for things like big overhead bridge cranes.
Absolutely. Preventing crashes between equipment or equipment and structures saves a lot of money and potentially lives.
And also prevention of access to loading areas where you might have those autonomous mobile robots, the MIRs, zipping around.
Yeah, keeping people out of the path of automated guided vehicles.
And even things like anti-tampering and anti-rotation detection, just for general injury prevention around machinery. It's quite a list.
It is. And what's important for you listening to this is how these applications directly benefit operations. We're talking fewer accidents, obviously, but also much less downtime. Downtime from actual incidents, but also from those false alarms we talked about. It really boosts the overall safety and efficiency of the plant.
Okay, but safety systems need to be trustworthy, especially advanced ones. How do we know these radar systems are actually reliable, that they meet industry standard?
Yeah, that's a perfectly valid question. And the key here is certification. Both sources mention IEC TS 614965.
Okay, what is that?
It's an international technical specification. It specifically defines how radar protection devices, RPDs, they call them, should be tested and validated. It sets the requirements for their performance and safety functions. So it's the rule book, essentially, to prove they work correctly.
And on that note, Inspect makes a pretty significant claim. They say they are the first and only company that built a sessile-rated radar sensor, and the first radar sensor certified for industrial safety. Is that as big a deal as it sounds?
It is quite significant, yes. Achieving that sessile rating, especially SIL2, which is often mentioned for these devices, means it's gone through very rigorous independent testing and validation against those IEC standards. So for a user, that certification provides a high level of assurance. It means you can trust the device for safety-critical applications and helps meet regulatory requirements. It's about documented, verified reliability.
Okay, so pulling it all together then, this 3D safety radar seems like a really quite a sophisticated answer to that old problem of keeping people safe around machinery in tough environments. Its ability to see through dust and smoke where other sensors fail, that seems like the real game changer for preventing accidents and keeping things moving.
I think so too. It represents a really important step forward in how we integrate people and automation, making those shared workspaces safer, but also more efficient. And it makes you think, doesn't it? If safety radar can reliably work in these really challenging industrial settings, heavy dust, fumes, liquids where optical sensors are basically useless, well, what could that mean for the future? Think about automation in even tougher places. Maybe deep mining, space exploration, disaster response zones, environments far harsher than a factory floor.
That's a really interesting thought to leave folks with. Where else could this robust sensing go?
Exactly. It opens up possibilities.